In this presentation, I will talk about an overview of prevention mitigation against memory corruption attack. This paper has been done by Mahmoud Jassim Khalsan with Michael Apoko, Department of Computing, University of Northampton, UK. Here we have list of contents, introduction, buffer overflow, the current techniques against memory corruption attack, and conclusion. In the past 2 decades, memory corruption attacks have captured the attention of security research community. The first organized worm that exploited a memory corruption attack to separate itself was called the Maurice worm. This kind of attack is well known for its high exploitability that allows the attackers to simply execute arbitrary codes. It takes control of the remote code execution according to latest Microsoft report. Here we have some techniques can be used by attacker to attack memory, which is all of them use buffer overflow. Buffer overflow can be defined as it happens when data size reaches the out of bounds. The techniques that used stack relied buffer overwritten attack, heap relied buffer overwritten attack, and block started by sample relied buffer overflow attack, and finally we have other hacking techniques relevant buffer overflow. Should we start with the first one, stack relied buffer overwritten attacks? In this part of a study, we produce that how attackers can exploit attack stack-based buffer overflow. As we mentioned previously, that buffer overflow occurs when the input data size is which should be handled by buffer is larger than the size of the buffer itself. The second technique that used by attackers to attack memory is heap relied buffer overwritten attacks. It can be defined as it happens once a chunk of memory is assigned to heap. Also, data is typed to this memory with no limitation of checking the size of the data that have been overwritten. Enhance this kind can be allows attackers to overwrite some important data structure in the heap, for instance the heap header. Third one is a block started by sample relied buffer overflow attacks. The whole idea of a block started by sample, or we can say it BSS, is any program starts running all variables, either local or global, which are not assigning value as initial, or these variables initialized with 0 for these variables. BSS will generate automatically. Consequently, the BSS area result buffer overwritten in the buffer which has been created as BSS area. Subsequently, the BSS area can be exploited by some hackers to overwriting some data. And finally, we have other hacking techniques relevant buffer overflow. In fact, we have 2 types of them: format string exploit and we have integer overflow. The first one, format string exploit, the vulnerabilities of these kind of techniques are resulted by incorrect invocation of some of functions like printf, sprintf, and others. Attackers can exploit that by entering incorrect data for the first parameter of the printf. The second one is integer overflow. It happens once doing an operation such as multiplying for 2 numbers and the result of the operation is too large, which it succeeds the range of algorithm expression. which determines for data type that cause buffer overflow, as explained previously in buffer overflow section. Here we have data execution prevision. This technique is used to force the memory to be writable with no possibility to be executable, or it is executable but must be readable only, such as code segments. The protection technique has developed in order to handle or at least reduce the normal exploits, such as the vulnerabilities that attack by existing code or writing malicious code inside data segment. The second one is ARMOR. This technique utilized with sharing library. As we know, sharing library provides ability to extend some external codes which executed in runtime. So some attackers exploit this vulnerability to inject vector into memory. The third technique is address space layout normalization. The main aim of address space layout normalization is to prevent attackers of executing shelled code in stack area or heap area. Additionally, share libraries by normalizing them. In fact, we can take two advantages of using this effective protection technology. Firstly, it can defend against remote attacks. Secondly, local attacker wouldn't be able to attack memory because of randomly offsetting memory structure and model-based addresses. The final one is kernel address space layout normalization. This mechanism attempts to normalize both program and data locations in kernel area when the kernel starts up. We have another techniques have been used with compiler and linker countermeasures against memory corruption attacks. First one, we have integer overflow to buffer overwriting. It occurs when the output of any calculation, such as multiplication or division by or dividing by 0, is surpass the range of the data type. And we have address synthesizer. It uses to detect 6 types of ways that used by attackers to hack the memory. The 6 types can be listed as following: out of bounds, use after free, use after return, use after scope, double free, invalid free, and memory leaks. And we have stack mashing protector, utilized to detect the return address has been modified before the function returns by inserting canary word underneath return address on the stack. And finally, we have automatic fortification. It's used to prevent format string stack. Also, we have with compiler and linker countermeasures stack shelled protection. The key idea is to copy the return address and keep it in somewhere that shouldn't be overflowed memory space at runtime. Other techniques against memory corruption attacks. Firstly, we have instruction set normalization. It uses to prevent run-oriented programming attacks. And we have pin. It used to defend against return address. It works as following: when the program starts running, it is potentially analyzes and create binary translation for the code that has been inserted by user. And finally, we have conclusion. In this paper, we highlighted some important and common techniques that can be exploited by attackers to hack memory. Additionally, we present existing countermeasures that have been used to prevent or minimize memory corruption attacks. Thank you for listening.